All right, so today is the last section of Chapter 8. It is on the compositions of reflection. So what this section is showing us is that any isometry can actually be expressed as a composition of reflections. So if you look at these two theorems, it explains that. So if you reflect a figure twice across two parallel lines, that is actually the same as a translation, which is just a slide. So you can do that. Or if you do two reflections across two intersecting lines, that will actually end up to be some kind of rotation. So both a translation and a rotation is really just a composition of two reflections. So it's just two reflections combined. That's what the composition means. So this last theorem here just states that in any plane, one of two congruent figures can be mapped to the other by a composition of at most three reflections. So as long as a shape and another congruent shape are in the same plane, you can get from the first shape to the second shape with at most three reflections. It could take fewer, but that's the most that it will take. So that's just something interesting to think about. Some problems that you're going to come upon are it's going to ask you to do just different types of reflections. So the first one is going to be a guide reflection, which is a composition of a translation and a reflection across a line parallel to the direction of the translation. So this example is going to walk us through a guide reflection. So it says, what is the image of triangle TEX with those points if we have a glide reflection where the translation is this, which is just telling us we're going to shift it down 5, and then we reflect it over the line x equals 0. So let's first start by plotting those points. T is at negative 5, 2, 1, 2, 3, 4, 5, up 2. E is at negative 1, 3, 1, 2, 3. And x is at negative 2, 1. So T, E, X, triangle T, E, X. Let me grab my straight edge. Okay. So there's our original figure. All right, so the first thing we're asked to do is a translation. The translation rule says to x is staying the same, the y values are going to go minus 5, so it's going to shift all of these points down 5. So for this first one, I'm just going to move them all down 5. 1, 2, 3, 4, 5. So I'm just going to make some minor points. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And I'm not really going to draw that one because I'm going to go ahead and do a reflection. And the line of reflection is x equals 0. So remember, x, we would be on the x-axis at 0, and it's the line opposite of direction of the axis that we're on. So really our line of reflection is the y-axis. So remember, to do a reflection, you just ask yourself, what's the shortest distance to that line of reflection, and then do that again. So at this point, it takes 1 to the right to get to that line of reflection, so I'd go 1 more to the right. This one takes 2 to get to the line of reflection, so I'll go over 2 again. This one would take 5 to get to the line of reflection, so I will go 5 over to the right again. 1, 2, 3, 4, 5. And then you just got to kind of think about where these points were. So this was E. If I reflected it, that would be E prime there. This one was X. Reflection is now there for X prime. And this one was T, the reflection point over there, T prime. So that's the one. I don't really need to make that one connected, but the final figure, we're going to go ahead and connect that. So this isn't really it's not really talking about the theorems above. It's just its own thing, a guide reflection. So it shifts it and then reflects it. So that would not be talking about that theorem up above. And I think on the back we've got another guide reflection, so we can try that one out. We'll do it together as well. It says, Oh, we're keeping the same points as before, so let's see, -2, 1, -1, 3, and -5, 2. And it was TEX like that. TEX. Okay. So we'll go ahead and connect those points. All right, so we'll look at our shift. So this one's going to be a little bit messier because I'm looking at our translation, and we're just moving the x values one to the right. Y is staying the same. So I'll use a different color for this one just to help keep it in line. So all the points are just moving one to the right. And then I'm going to reflect it across the line y equals -2. So that would be down 2 on the y-axis. That line is the opposite direction of the axis that I'm on, so it's going to be this horizontal line. And then just like before, you ask yourself, what's the shortest distance to get from the point to the line of reflection? So from T, the new T, we go down 1, 2, 3, 4. So I would go down 1, 2, 3, 4 again. So there's T prime. E, I go down 1, 2, 3, 4, 5, and then down 5 again. 1, 2, 3, 4, 5. E prime. And then X's new point right there, it would take down 3, and then down 3 again. 1, 2, 3. And that would be X prime. Connect all those points, and you've got your guide reflection done. So this isn't difficult, it's just kind of a review really of the previous sections that we've talked about. The last thing, you'll just see some of these examples in your problems, so I just want to make sure it all makes sense. So you're going to have pictures like this, and it's going to ask you which isometry is it? Is it a translation? The orientation is the same. Or a rotation? The orientation is still the same. You'll notice you can still read the R. It hasn't been flipped around. In a reflection or a guide reflection, the R, the image is going to be a mirror image. It's going to be backwards. So this is the final result of a guide reflection. It's slitted and it's been reflected. So for translation and rotation, you're still able to read the original image. And a reflection or a guide reflection, the orientations are going to be opposite. So we've got those 4 options. So it's going to walk you through that. Are the orientations the same or opposite? So that'll narrow it down to 2. And then which one does it follow out of those 2? So if we look at this pre-image, it says turn, to that pre-image, that one's obviously backwards. So the orientation is opposite. So that narrows it down to either a reflection or a guide reflection. Well, these aren't perfectly lined up to each other like a reflection would be. So this one's going to be the guide reflection. If we look at the next one, same image, same pre-image. And if you look at the image, if you rotate your paper around, you can still read that. It still says turn. So the orientations are going to be the same. And then obviously it's not a translation because I had to rotate my paper around to be able to read it. This is going to be a rotation. And 3 more examples of it. If you look at this one, the pre-image and image are not opposites. They are the same. They're not in the same orientation. So that one is also going to be just a rotation. This one, the pre-image and image are exactly the same. So the orientation is the same. And it looks the exact same. So this is just going to be a translation. And then on the last one, the pre-image and the image, this one, if you flip it around, that's not a P anymore. So the orientation is going to be opposite. And again, they're not lined up. They're not spitting mirror images, right? This one's upside down. So this one, again, is going to be a glide reflection. So we didn't see a true reflection, but if you see that they are just mirror images of each other, it hasn't been rotated around at all, then that would be the reflection. So keep your eye out for that. And then that's all there is for these notes. It's not that difficult. You guys will do just fine. So good luck, and if you have any questions, please do ask.